Now let's talk about what makes an airplane stable and when an airplane will be stable. Now, if an airplane is stable, it'll fly along with very little effort to control. So an airplane that is said to be inherently stable will require less effort to control if it's inherently stable. Now, when we're talking about stability of an airplane on the FAA exam, normally talking about longitudinal stability. Now, longitudinal stability means pitch stability. Does the airplane tend to pitch up or down and get out of control, pitching up and down? Well, most airplanes are built so that if you pull up on the elevator and pull the nose up and let go, the airplane will return to equilibrium. And if it oscillates, the oscillations will get smaller and smaller and smaller. That's called longitudinal stability. Now, what determines the longitudinal stability of the airplane? Well, the location of the center of gravity in relation to the center of lift. Let's take a look at it. Most little airplanes are designed so that the center of gravity is actually in front of the center of lift. Now watch what would happen if you pick this airplane up by a string here at the center of lift. Well, if you pick it up by a string right here, the center of gravity is in front of the center of lift, and the airplane would nose down. Well, most airplanes actually are designed that way, so why aren't they nosing down all the time? Well, because the tail actually has an aerodynamic downforce on most airplanes. The tail is actually trying to fly down. Now let's take a look at what that does for you. Here you are flying along, and if you're flying at a speed that is just right for this airplane, this aerodynamic downforce on the tail exactly balances the weight being in front of the center of pressure, and therefore the airplane is flying along just in balanced condition like so. Now let's assume this airplane for some reason gets a little bit slow. That means there'll be less air over the tail. Now what's going to happen is the tail will come up, the nose will go down, the airplane will dive and pick up speed, and the airplane will now have more air over the tail, the nose will come right back up and return to its original speed. So this aerodynamic downforce on the tail helps make the airplane stable as far as pitch and speed are concerned. So the reason this Piper Archer is flying along in straight and level flight, even though it's just a little bit bumpy, is that the airplane is inherently stable. And the reason it's inherently stable is there actually is an aerodynamic downforce on this tail. This tail is trying to fly down. And the reason the tail is trying to fly down, well, the center of gravity is in front of the center of pressure. Now, you can't change the center of pressure much, but can you change where the center of gravity is in an airplane? You certainly can. All you have to do is load bricks in the baggage compartment. You can move that center of gravity around. And when you're doing that, you're changing the stability characteristics of the airplane. For instance, let's you and I move the center of gravity further rearward. Now there's less aerodynamic downforce on the tail. It's the aerodynamic downforce on the tail that makes the airplane stable, so therefore the airplane is less stable. So let's assume you load an airplane further aft. Do you change the stability of the aircraft? You certainly do. Let's load the aircraft to the most aft CG limit back here. Will the airplane be more or less stable? Well, if you load that airplane to the most aft CG limit, the airplane will be less stable at all speeds. How about you load the airplane aft of the allowable rear CG limit? What would happen then? Well, if an airplane is loaded aft of the aft CG limit, the pilot just might experience difficulty in the stability of the aircraft and in recovery from a stalled condition. Because if you have the CG too far aft, you might have difficulty getting the nose down for recovery from the stall. And therefore, you fall all the way down to the ground tail first. Personally, I will never fly an airplane loaded aft of the rear CG limit again. All right, let's take a look at now what happens in an airplane when you have air flowing over the tail. When you're flying along normally, most airplanes, except for T-tail type airplanes, you have the air from the propeller flying over the tail. Now, would that increase or decrease the down tendency, the tendency of the tail to fly down? And the answer is it would increase the tendency of the tail to fly down. So if you remove the power, for instance, you reduce power and you have less air flying over the aircraft from the propeller slipstream, what's going to happen to the aircraft? And the answer is it will have a tendency to nose down because it'll reduce the downforce on the tail. So the nose-down pitch tendency of an airplane when power is reduced, except for T-tail airplanes, occurs because the downwash on the elevators from the propeller slipstream is reduced, and also because elevator effectiveness is reduced because there's less air going over the elevators. Now, I said earlier, it's pretty easy to move the center of gravity around in an aircraft. I mentioned putting bricks in a baggage compartment. I didn't say one thing about putting the mother-in-law in the back seat. I didn't say anything about that. But anyway, you can move the center of gravity pretty easily. But I said earlier, it's very difficult to move the center of pressure around very much, but actually, I lied to you because you can move the center of pressure. All you have to do is put the flaps down, you increase the lift at the back of the wing, and the center of pressure moves aft. Or you can put the airplane in a very low angle of attack, like when you're flying fast, and when you're at very low angle of attack, the center of pressure moves aft, and you once again have more distance between the center of gravity and the center of pressure and more downforce in the tail, and at very high speeds, the airplane becomes more stable. But if you change the angle of attack by flying very, very slow, now you have the nose pitch way up in the air and the center of pressure moves forward, and there's less distance between the center of gravity and the center of pressure. And when you're flying at very high angles of attack, there's less downforce in the tail and the airplane is less stable. So just like changing the center of gravity, changing the center of pressure, mostly by changing your angle of attack, will affect the aerodynamic balance, controllability, and stability of the airplane.